Good morning, students. Yes, students. In last class, we were seeing the um, yesterday. In last class I have started the new module, that is fifth module. In the fifth module, we are going to learn the fault-based testing, planning, monitoring and documentation. So this is a prescribed book you have to use for this fifth module, and we have done with the introduction part and the assumption in fault-based testing. Assumption in fault-based testing, and here some of the So yesterday we have seen the fault-based testing. So what is fault-based testing is, students, in the last module we learned the system testing. In system testing, we are checking about the system, the working of the system. There, our intention was not to find the fault in the system, just to check whether the system is working properly or not. Here we are checking the faults. Here we are here some of the assumptions. In last class I told you some of the examples of, or some of the types of errors or types of faults we do when we write a program. It may be a syntax error, it may be a syntax error, it may be a logical error, or it may be a typo error. Yes, students, we have seen, no? In last class, it may be the program may contain a small syntactical changes, syntax error. Instead of less than symbol, I would have written a less than or equal to, or instead of less than or equal to, I would have written less than symbol or greater than symbol. Some minor change, minor mistakes I would have done while writing a program, and even the typo error also we have seen. So this small example I told last class. See here, students, this I want to check whether the given year is leap year or not. The formula is year mod 4 is equal to 0. Now what I do is, instead of year mod 4, I write year into 4 is equal to 0. See, according this, there is no here what happens, students, there is no syntax error. Here it is a logical error. For this logical error, I have given this example like this. We do a mistakes in the program. So our intention in fault-based testing, what is the aim of the fault-based testing is to find the faults in the program. Find the fault in the program. So here some of the examples, the fault-based testing terminologies. Here, students, this is clear now, or you want me to zoom? Clear agidya screen now? The PPT is clear. The fonts are clearly
Yes, ma'am.
visible.
Yes, ma'am. Clear.
Okay.
Clear,
The
ma'am.
first, see, first is the first one is a original program. Original program. So what is the original program is year. I'll continue with the same example. Year mod 4 is equal to 0. This program I may be using with C program. I have written the code in C or in Java. This program is to be tested. This program I want to test. So this program I want to test the program location, a region in the source code. The precise definition is defined relative to the syntax of a particular programming language. Typical location are statements, arithmetic and Boolean expression, and procedures calls. So for here in the program location, first we'll see the program definition, the syntax and the programming language. See, the syntax and the programming. See, students, though the logic is same, the syntax may be different from one language to another language. Correct, no? Though the logic is same, the syntax may be different from one programming language to another programming language. So in the fault based, first we'll see the source code, then we check the programming language and the location for the arithmetic expressions, Boolean expressions, and the other procedure calls we'll see, and the alternative expression. Alternative means the alternative solution. The other, if not this, then the other one. So that we call as a alternative. So alternative expression, source code text that can be legally substituted for the text at the program location. A submission is legal if the program, if a submission is legal if the resulting program is syntactically correct. Yes, if the program is not having any error, if the program is not having any error, see here in the bracket it is there. That is compiles without any error. If we when we compile the program, if the program is not having any error, then we can submit the program. Correct? See, I'll take your lab exam only. When you got third program. In third program is quadratic equation program. So quadratic equation using C program, you have to develop using C programming language. You have to write a program for quadratic equation. Once if you have a error in the program, if you call the external or internal stating that I have executed the program, when they come and check, will they satisfy? So what they say, they will scold, or they will tell that without your program has so many errors, without executing the program, why you are calling the examiners to check your program. See, the checking when we are calling examiners to check our program is nothing but we are submitting the program to them. So we are telling that I have executed this program. When we tell that, when our program is not having any error. So when I compile the program, when my program is not having error, then legally, then I call the examiners to show the program. So similarly here, when my program is not having error, syntactically, logically, everything is right, then legally I can submit the program. Alternate program, a program obtained from the original program by substituting an alternate expression for the text at some program location. Yes, students. See, this is the formula. Yes, is it a correct formula to find the given year is leap year or not? Is it a correct formula, students? Yes, it is a correct formula. Now, once I submit this program, I'll get a correct output. When I show this to the examiner will tell, yes, you are getting the correct output, your program is not having any error. Then they may tell us to modify the program or alter the program. So what I do here I am dividing the year only by 4. Here they may ask you to divide the year by 400 and 100. Yes, in Visual Studio I have shown this program. In Visual Studio I have shown this program. So now initially for the input, whatever the required input is there, so I am getting the output. Once I submit this program, if without any error, then they are asking that submit the alternative program. Do the alteration in the program, do the alteration in the expression, and submit the program. What alteration? Here this logic will not give a correct output for 100th year. This logic will not give a correct output for the 100th year. So now I have to check the year for 400 and 100. So this is the this is the alteration in the program. So once yes, students, this is a small change in the program. If after changing, if I'm not getting, I have to check the behavior of the system program. So once I change the logic, I have to check the behavior of the program. Yes, this is the correct logic. Instead of 400, if I give 300, then though it is not having a syntax error, though it is not having a syntax error, but the behavior of the program will change. The behavior of the program will change. So whenever we are doing some alteration to the program, the behavior of the program or the output of the program should not change. The output of the program should not change. So this is what we are doing in a fault based testing. So next we have a mutation analysis. What is mutation, students? What is mutation? Yes, listen carefully, students. Mutation testing or mutation analysis involves modifying the program in a small way. This mutation involves modifying the program in the small way. Mutation involves modifying mutation involves modifying the program in small way.
Ma'am, change the color, ma'am.
Yes. Yes, students.
Ma'am, color change ಮಾಡಿ
Yes,
ma'am, ಅದು ಕಾಣ್ತಿಲ್ಲ.
you want to tell anything? Yes, students.
Ma'am, color change ಮಾಡ್ರಿ ma'am, ಅದು ಕಾಣಲ್ಲ.
Color. Okay, I'll change. Is it fine now?
Yes, ma'am.
So here, the mutation analysis. Mutation analysis is nothing but I can say mutation. Mutation is nothing but, or mutation testing is nothing but, mutation involves modifying a program in a small way. Yes, students, we are not changing the entire program. Students, we are not changing the entire program. We are modifying, or we are changing, or we are altering the program in a small way. It may be a data type. It may be a data type, or it may be a smaller minor changes in the expression. Some changes we are doing in mutation analysis. What we are doing some changes. But that change is not a larger changes. That change will not change the behavior of the program. That change should not change the behavior of the program, whatever the changes we do. Say, for example, I'm writing a program to add two numbers. Writing a program to add two numbers. So what I do, first I have declared a variable as integer, students. Int ABC. Int ABC. This is the program I have written. And my expression is B plus C plus A. Can I write like this? Students? Or I'll write like this. I have declared a variable. Yes, students. Are you understanding? Here I have declared a 3 variables int a, b, c. The expression is a is equal to a plus b plus c. Yes, the output I am storing in the variable c. Sorry, output I am storing in the variable a. Is it right? Can I write like this the expression? Bariಬಹುದಾ ಈ ತರ? Yes, Chaitra, can I write like this? Yes. Yes, here I have declared, this is my original program, students. So what I do here, instead of integer, I'll declare the variables as float. I'll declare or I'll modify the variable as float. Is it affecting to my program? Is this small change affecting to my program, students? No. Here, instead of integer variable, I have declared as a float variable. And this variable changes, variable declaration modification I have done. Variable declaration modification I have done, and this is not affecting to my, this is not affecting the, or this is not changing the behavior of the program. So finally, what I have to calculate? I have to calculate the sum of these three numbers. If whether it may be integer variable or it may be float variable, the output is not changing. The behavior of the program is not changing. Yes, is it right? Correct? Now, see here, the expression is a is equal to a plus b plus c. This expression, I'll write like this. Is it correct? Can I write like this? Can I write like this, students?
Yes, ma'am.
Yes, I can write. Yes, here my original program is int abc and a is equal to a plus b plus c, and I am displaying the output with the variable a. So this is my original program, students. Now what small modification? This modification is nothing but the mutation in the program. Yes, understanding the small changes. Mutation, see, mutation involves modifying and testing. The mutation analysis involves modifying and testing. Here, after doing the modification, simply I don't keep quiet. I'll test. How I test? I'll run the program and I'll check whether it is affecting to my program, whether my program behavior is changing. Yes, students, understanding? Whether my program behavior is changing. I'm checking here. Yes, if I declare here, after changing the variable integer to float, it is not affecting the behavior of the program. The mutation is accepted. Correct, Alva? The changes is accepted because it is not changing the behavior of the program. The output is not changing. Here previously I have declared as integer, I have changed that to float. Now with the shorthand operator, instead of writing a is equal to a plus b plus c, I have written a plus is equal to b plus c. Yes, this is also a correct way to write this expression. This is also correct way to write this expression. Yes, students, am I doing the modification here? Yes, I am doing the modification, minor modification I am doing in the expression. In the when I am writing the logic, in the logic I am doing the changes. In the logic I am doing the changes. I am doing some modification. I am doing some modification. Is it affecting to the behavior of the program? No, it is not affecting to the behavior of the program. So the mutation is accepted. If the behavior is changing, then the mutation will be rejected. Yes, students, not only this program, whatever the program you develop, or whatever the project you develop, if the mutation or if the modification or if the changes is changing the behavior of the program, or if the changes is changing the output of the program, then that mutation will be rejected. Yes, this you keep in your mind. If we do any alteration or if we do any modification to the program, to the existing program, if that modification or if that alteration is affecting the output, then that mutation will be rejected. If it is not changing the output, or if it is not changing the behavior of the program, then that mutation will be accepted. ಅರ್ಥ ಆಯ್ತಾ? ಯಾವಾಗ ನಾವು ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ತೀವಿ, ಯಾವಾಗ ನಾವು ರಿಜೆಕ್ಟ್ ಮಾಡ್ತೀವಿ ಅಂತ. ಸಿ ಮ್ಯೂಟೇಶನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದ modification and the test. Modification and testing the program. So if here I'm instead of just a variable modification I have done, and here the expression modification I have done, it is not changing the behavior of the program. So the mutation is accepted if it changes the behavior. If it changes the behavior, if I do star, a star is equal to b plus c. See, it is not having any syntax error, it is not having any logical error, students, but it is not satisfying my need. My need is to find the sum, but here the multiplication is doing, so this mutation is rejected. Artha aita? So this mutation is rejected. So the mutation analysis is done on the mutation analysis is done based on the fault based testing, and each variant is called a mutant. Here variant is nothing but variant means what is the meaning of variant? Variation. Again, I put it like this: each variation is called mutant. Variation means what, students? Variation andre ಏನು? Changes,
ma'am. Different.
Yes, changes. Yes, good. Changes. So variants are created by seeding fault, that is by making a small change to the program under test following a pattern in a fault model. The pattern for changing the program text called a mutation operator. See here, what changes I have done here. Instead of integer, I have declared the variable float. So this float is a mutant operator. This float is a mutant operator. So the pattern which we are using, the pattern for changing the program text are called as a mutation operator, and each variant is called as mutant. Or I put it like this: each variation is called mutation. Each variation is called mutation. And the mutant program that are rejected by a compiler, or that fails almost all tests, if that is failing. Here I told the students, if the program behavior is changing, if the program output is changing, then we reject the mutation, we reject the mutant. So the mutant program that are rejected by compiler or that fails almost all tests are not good models of the faults we seek to uncover with systematic testing. Sorry. So here in the simple words I told you that if the changes or if the mutation is affecting the behavior of the program, then that mutation will be rejected. We say mutant is useful. If in addition to being valid, its behavior differs from a behavior of the original program for one or more for no more than a small subset of a program test case. So we say the mutant is useful if the addition of the changes or the addition of the mutant is valid. If it is not differing the behavior of the program, then we say the mutant is useful. And the mutant is valid if it is having a syntactically correct. If it is not having any syntax error, then we say as a mutant is valid or mutation is valid. Yes, students, here mutant is nothing but, or the mutation is nothing but the modification in the program or the changes in the program. Once I do the changes, it should not change the behavior of the program. If it changes the behavior of the program, then that is not a that is not a valid mutant. That is not a valid mutant, and that changes is called as a mutation operator. That changing text is called as a mutant operator. And the mutation, what or the changes what we are doing in the program, that should be syntactically correct. It should not be having a syntax error, and it should not change the behavior of the program. It should not change the behavior of the program. So here the mutation analysis terminologies. Original program under test. So first the original program will be tested. The program or the procedure or the function to be tested. The mutant, a program that differ from the original program for one syntactic element. The program that differ from a syntactic element. The syntactic elements are the statement, the condition, or the variable, or the label. Yes, students, I told you I should here in the, that's why I have taken this empty PPT slide and I have written here. Yes, here the variable I'm entering, variable changes I'm doing. Instead of integer, here I have taken float. Here the expression I am changing. Expression change aita illi. Here, instead of writing a is equal to a plus b, I have written a plus is equal to b plus c. Correct? Yes, students, is it right? So I have done the changes here, and here even the here generally what we do to check year to find the leap year, we check year is equal to year mod 4 is equal to 0. So this is one condition. Next, and year mod 400 is equal to 0, and year mod 100 is equal to 0. Yes, students, I'm changing the logic condition also. I'm changing now here in case of leap year. Here, if I change the condition, is it affecting to the program behavior? No, it is not affecting to the program behavior. All these types of changes I can do in the mutation. The same thing is here. You can change the mutants are a program that differ from the original program. That is a statement change, condition change, variable change, and the label change. If these changes we do, then it should not change the behavior of the program. It should not change the behavior of the original program. If it is changing, then the mutant is rejected. If it is not changing, then the mutant is accepted. Distinguished mutant. A mutant that can be distinguished for the original program by executing at least one test case. So at least one time we have to test, at least with the one variable we have to test. If it is not matching, then reject. If it is matching, then the mutant will be accepted. Equivalent mutant, a mutant that cannot be distinguished from the original program. And the mutant operator, a rule for producing a mutant program by syntactically modifying the original program. So the mutant operators are here, whatever the changes we are doing. See, these are nothing but a mutant operator. If students understood this, this is not complex, this is very simple. The mutation, you understood the mutation concept? Artha aita? Yes?
Ma'am.
Any doubt? Any doubt, students, in mutation and in mutation analysis?
No, ma'am.
So here is a small code snippet they have given. So just it is a simple program. Next we have fault based adequacy criteria. Fault based adequacy criteria. Adequacy means capacity or the sustainability. So here we are doing fault based adequacy, here fault based capacity criteria or fault based adequacy criteria. Here what we do, select the mutation operator. First we need to select the mutation operator. Here yes students, here first I have declared the variable as integer. I have changed the variables to float. So there a float is a mutation operator. Float is a mutation operator. And here in this expression, I have written first, initially I have written a is equal to a plus b plus c. Again, I have used a shorthand operator. Using a shorthand operator, I have written like this: a is equal I have written a plus is equal to b plus c. So here this shorthand operator is a mutator operator. Correct? No. So first you have to select the mutator operator, mutation operator. Select the mutate operator or mutation operator. If we are interested in specific class of fault, we may select a set of mutation operator relevant to those faults. So assume that if I am having a list of mutation operator, if I'm having a list of mutation operators, select a mutation operator which is suitable for the specific program or suitable for the specific a project. So based on the situation, yes students, here I have other variables also. I have a character variable, I have long variable, I have a boolean variable, I have a float variable, decimal variable I have. So here can I use character variable? Yes students, can I use a character variable? No. Why I cannot use a character variable? Because here I want to add 3 numbers. When my agenda or when my aim is to add 3 integers, then I can, if I take a character variable, or if I take a character variable as my mutation operator here for this specific program, then my assumption is wrong. Correct? No, my assumption is wrong. So based on the situation, we have to select the correct operator. Though I have integer variable, float variable, character variable, even boolean also we have. And long variable, long integer also we have. If instead of integer I could have taken here long. I could have taken here long and I have taken here float. But if I take boolean, if I take character, is it valid? Yes, students, are you following this example? Are you following this example? Respond. Or any confusion?
No, ma'am.
Yes? All of you are following this example?
Yes, ma'am.
Yep. So here, the instead of integer, if I take character or boolean value, then the mutant, definitely the mutant will be rejected. Why? Because here I am calculating sum of three numbers. So here, first you select the proper mutant operator. First, the selection of a proper mutant operator is very much important. It should be relevant. It should be relevant and generate the mutant. This generation of mutant is nothing but a once you to the original program after doing a modification, that modified program is nothing but a generation of a mutants. That is nothing but a generation of a mutant, or or you can also say as a modification of the original program. Modification of the original program. Mutants are generated mechanically by applying the mutation operator to the original program. Yes, to the original program. If you do any changes, or if we apply the mutation operator, then applying a mutation operator is nothing but a mutant generation. Distinguish mutant. So we have to distinguish the original program and the mutant program. Previously, with the original without a mutation, how the behavior of the program. After the mutation, how the behavior of the program, that we have to distinguish. A mutation can remain alive for two reasons. What are the general? See, without seeing this only, you should say, students. So, which are the two reasons? The first reason is it should not affect to the existing program. It should not. Yes, here I told no. In this, here I told if it is not affecting the existing program, then only the mutation is accepted. If it is affecting to the existing program, then the mutation will be rejected. So here a mutation can be distinguished from the original program, but the suits T. This T is nothing but the test case. T does not contains a test case that distinguish them. That is, the test suit is not adequate with respect to the mutation. So, if the test case is not suitable, with the with respect to the mutation, then we are going to reject the mutation. So the meaning is whatever the mutation we are applying should not distinguish the original program. If it is distinguishing, then the mutation will be rejected. The mutation cannot be distinguished from the original program by any test case. Whatever the test cases we apply, it should not distinguish from the original program. For these two reasons, the mutation will remain, or we can say the mutation can be accepted. The mutation can be accepted. The variations on mutation analysis. Variations on mutation analysis. See, students, mutation is nothing but a changes in the program. Mutation is nothing but the change in the program, and how that change should be. How that change should be. It should not change the behavior of the program. It should not change the behavior of the original program. If it is changing the behavior of the program, then the mutation will be rejected. If it is not changing the behavior, then the mutation will be accepted. The computational effort required for mutation analysis can be reduced by decreasing the number of mutants generated and the number of test cases to be executed. How we can reduce the number of mutants in the program, students? How we can reduce the number of mutants? if I reduce the number of changes, if I reduce the Yes, students, this is my original program. This is the original program, and this is a modified program. This is a modified program. Here I don't have any mutants. Here I have added the mutation in the program. How I can reduce this number of mutation? How I can reduce the number of mutation? If I reduce the number of changes, if I reduce the number of changes in the program, then definitely I can reduce the number of mutations and the mutation operator. Is it right? Is it right? When the mutation increases, when we do more changes in the program, then the mutation increases. When you want to reduce the number of mutation, then we have to reduce the number of changes in the program. Then we have to reduce the number of changes in the program. It can be generated. It can be means the mutation analysis the mutations can be generated a number of mutant politic in the size of the program. Each mutant must be compiled and executed with each test case until it is killed. So each mutation or each changes, whatever the changes we are applying. See, simply I cannot add some variables, or I cannot add some functionality, or I cannot add some variable or some operator to the expression. If assume that if x plus y is my original program, so now what I do, a is equal to x plus y into z. So this is the functionality, this is a mutation I am adding to the program. Simply I cannot just add and I cannot go. After adding, definitely I will check. Definitely I will check whether this enhancement or this mutation is giving a correct output. So initially I want to just add two numbers. Now after sometimes I remember that I have to include one more variable with the multiplication. After sometimes I'll remember. So after that I'll add this multiplication variable, a multiplication operator and the variable to the existing program. Then this existing should give a desired output. It should give a desired output. So simply I cannot add these two, this operator and the operand, to this expression. After adding, I will compile and I will check. I will compile and I will test whether it is giving a correct output or the required output or my desired output. So I will check. So here, so I will check whether it is giving a correct output or not. So we have to check. So until the program terminates, or until the end of the execution, we check whether the mutation added to the program, whether it is right or wrong, or it is giving any compilation error, or it is executing properly or not. We are checking the time and space required for the compiling all mutant and for execution of all test case for each mutant may be impractical. So sometimes we cannot say how much time we need, how much space we need to execute or to run the changes or the mutants, whatever we included in the program. Weak mutation testing does not decrease the number of program mutant that must be considered, but it does decrease the number of test execution and compilation. See, all mutation or all changes, we cannot say those are all the strong mutations, or I cannot say those are all the I cannot say whether it is a strong mutation or it is a weak mutation. But the weak mutation testing does not decrease the number of mutation. See, mutation changes is changes. I cannot say it is a strong change, it is a weak change. If I am changing a simple variable, also that is some changes. I am doing some change. I am here. I am not telling that whether it is a weak change or it is a strong change. It's a weak change or it is a strong change. Weak mutation testing does not decrease the number of program mutant that must be considered, but it may reduce the execution and compilation. It may reduce the number of execution and compilation. So this is the mutation analysis. This is the variations on mutation analysis, students. Yes, students, understood? Understood? Any doubt?
No, ma'am.
Okay, students, I'll stop here. So today's assessment, the link I'm sharing in the chat box. Students, any doubt? Yes, students, I'll repeat. I'll just give the summary of this. Listen carefully. Here, after the fault-based testing, what we are doing, we are applying a mutation to the program. That mutation is, that word mutation, mutant is nothing but a variation. That variation means changes. The general meaning of variation is changes. So the changes we are applying to the program. When we do any changes or when we do any small changes to the program or seeding last class only I told the inserting. So when we insert any changes to the program, it should not change the behavior of the program. When it is changing the behavior of the program, then that mutation will be rejected. That mutation will be rejected. And here I have given some of the example. Here the variable changes I am doing, the expression changes I am doing, and here the logical changes I am doing. All this will not affect the behavior of the program. Will not change the, it will not affect the behavior of the program. And fault-based accuracy adequate criteria. So here we are checking the capacity of the mutation. The mutation operator, the changes where we do, that is nothing but a mutation operator, and it generates a mutation. And the mutation, if it is accepted, if the mutation is accepted, then definitely it should be different from the original program. And here we have the variations on the mutation analysis. So any doubt, students? So the assessment link I have shared in the chat window. Assessment link I have shared. All of you answer for the assessment. I'm giving you 5 minutes time to complete the assessment. Answer your attendance, students. Asta,
Yes, ma'am.
how are you, Asta, now?
I'm better now.
What happened?
Ma'am, actually viral was there, so
Oh. You call me after the class. Whenever you're free, in the tea break, you call me. Abhinav,
okay, ma'am.
Abhinav, Aishwarya,
Present, ma'am.
Ambrish,
Yes, ma'am.
Anu,
Present, ma'am.
Arbaz, Arbaz, Arjun,
Present, ma'am.
Ashok,
Present, ma'am.
Benita,
Present, ma'am.
Bhargavi,
Yes, ma'am.
Bhavisha, Chaitra,
Present, ma'am.
Dev.
Present, ma'am.
Dev, what happened to Abhinav and Arbaz? Why they are not attending? Do you have any idea?
No, actually, ma'am, Abhinav's father having corona, I guess, and Arbaz is I don't know where is Arbaz.
But now Abhinav is not staying with his parents, no? He's in Bangalore, no? In the parent teacher meeting, his father only told.
Yeah, but this time he stayed in Bangalore. I think now he going to his home in Delhi. I guess I don't know what is he.
Okay, okay. Diksha,
Yeah.
Present, ma'am.
Deepika L,
Present, ma'am.
Deepika M,
Present, ma'am.
Murli,
Present, ma'am.
Gangubai,
Present, ma'am.
Gudia,
Present, ma'am.
Harshit, Singh, Harshit absent, Junjar,
Present, ma'am.
Kavya,
Present, ma'am.
Kishore,
Present, ma'am.
Lata,
Present, ma'am.
Yes, ma'am.
Manisha, Manjunath.
Ma'am, present, ma'am. Present, ma'am.
ಆಯ್ತು
Ma'am, present, ma'am.
ಮಂಜುನಾಥ್ ಮಂಜುನಾಥ್ ಆಬ್ಸೆಂಟಾ ಮಂಜುನಾಥ್ ಮಂಜುನಾಥ್ ನಯನ
Ma'am.
ನೀಲಾಂಜನ್
Ma'am.
ನಿಶಾಂತ್ ನಿಶಾಂತ್
Present, ma'am.
ನಿಶಾಂತ್ ಇನ್ನೂ ನನ್ನಲ್ಲಿ ಬಂದಿಲ್ಲ ನಿಶಾಂತ್ ಪವಿತ್ರ
Present, ma'am.
ಮೈಥಿಲಿ
Present, ma'am.
ಪ್ರಿಯಾಂಕಾ
Present, ma'am.
ಪವನ್
Present, ma'am.
ಆಕಾಶ್
Present, ma'am.
ರಾಜೇಶ್ವರಿ
Present, ma'am.
ರಾಕೇಶ್
Present, ma'am.
ರಮ್ಯಾ
Present, ma'am.
ರಶ್ಮಿ
Present, ma'am.
ರವಿಶಂಕರ್
Yes, ma'am.
ರಿಜ್ವಾನ್
Present, ma'am.
ವಿಶಾಲ್
Present, ma'am.
ಸವಿತಾ
Yes, ma'am.
ಶ್ರುತಿ
Present, ma'am.
ಸ್ನೇಹ
Yes, ma'am.
ಸ್ಫೂರ್ತಿ
Present, ma'am.
ಶ್ರೀನಿಧಿ
Present, ma'am.
ಶ್ರೀನಿವಾಸ್
Present, ma'am.
ಸುನಿಲ್ ವೈಷ್ಣವಿ
Present, ma'am.
ವಿನ್ನಿ
Present, ma'am.
ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಆಬ್ಸೆಂಟ್ ಲಾಸ್ಟ್ 2 classes
Yeah, ma'am.